Welcome back to Spring Into Math 8. Today we're going to be doing the review lesson for Chapter 11. Let's go ahead and get started looking at all the topics we've talked about. The first topic we talked about in this chapter was two-dimensional congruent figures. So remember that the definition of two-dimensional congruent figures is the following. Figures that have the same size and same shape are considered congruent figures. Basically, also you should know that two-dimensional figures are flat shapes versus a three-dimensional shape is something you can physically hold in your hand. So when we're talking about two-dimensional congruent figures, these are things that you would maybe cut out of a piece of paper and lay on a table. So here's an image that will help you remember these things. We have a green rectangle and a red rectangle on our screen here. These rectangles are not congruent. However, they are the same shape, but they are different sizes. So if I were to lay the red rectangle on top of the green rectangle, you would notice that you would still see part of the green rectangle sticking out, which means that these are not congruent. However, we have a polygon here on the other side. One's yellow and one is blue. These shapes are congruent, same size, same shape. Also remember that matching angles are called corresponding angles and matching sides are called corresponding sides. In our image here, a triangle in red, triangle YXZ, is a congruent triangle to triangle LKM, which is in blue. We can see that they have corresponding sides represented by the small hash marks. So the bottom of the triangle has one hash mark on each triangle. That means they are the same size, same shape. And that goes as true for the other sides of our triangle that have two hash marks and three hash marks. Now we also have same or similar angles. So angle X is the same measurement of the angle of angle K inside the blue triangle. If the red triangle X angle was 50 degrees, then the corresponding angle on the blue triangle, which is angle K, would also be 50 degrees. All right, topic 2, transformations, which can be we have subcategories here. Translations, reflections, dilations, and rotations are used. Here's our example of a translation. We have our figure here, A, B, C, and D. Now this figure has been translated 7 units to the left and down 3 units. So if you took point A and moved it over 7 units to the left and down 3 units, your new point would be A1 and the opposite shape. A reflection example. We have our line of reflection, which is down the center of our image here. We have what looks like a regular E on one side, and the mirror image or the reflected image which has been flipped over the line of reflection, which gives us that nice reflection example here. A rotation. Now remember, rotations can be talked about in 90 degrees, 180 degrees, and so on. And we also remember that the point of origin is a very common place for us to rotate things around. So we have our green triangle here was rotated 90 degrees clockwise. And you can see that it ended up, if we were to do that, that would be our new triangle in purple. Now let's take a look at the purple triangle. If we asked you to rotate that 270 degrees counterclockwise, you would end up where the green triangle actually is. So remember, rotation is just rotating the image in a particular amount of degrees, such as 90 or 180. Dilation. Now this is a scale factor. We have a center point here, which is where these two lines meet. We have our original image of our tiger, which is the small one. And then we have our second image, which is the dilated image, which is made much larger than our original. If I were to guess how many times larger, the scale factor here would probably be 2 to 3 times the size of the original. In review for this particular lesson, we have a nice image here. It shows you what translations are, moving things side to side, up or down. A rotation, which means the image is being rotated a particular number of degrees. A dilation, which shows the original image in red, which is the small one, and the new blue one, which is much larger. And of course, our reflection, which also has our line of reflection built right into it. Great page for notes. Topic number 3, describing translations, reflections, and rotations. So you can see here our image is of a unique polygon. It has a line of reflection. See if you can figure out or draw or put your finger on the screen where you think the line of reflection is. I'll go ahead and do the same. My line of reflection has been drawn in a nice yellow color. you can see that the image, figure A, has been reflected over the line of symmetry or the line of reflection to make the new figure on the opposite side. Transformations. This is where an image is slid up, down, left, or right a specific number of units. So we can see that figure A has been transformed to make our new figure, which in this case is figure B. And it has been translated or transformed 1, 2, 3, 4 spots over and down 1 spot. So we would say 4 units to the right, 1 unit down. That would be how we describe the translation here in this particular image. Here we have a rotation of a rectangle. Our rectangle figure A is our original image, and rectangle B is represented by figure B, which is our new image. How many degrees do you think this image has been rotated? If you said 90, you got it correct. This image has been rotated 90 degrees clockwise. Clockwise and counterclockwise are very important terms to always keep a lookout for when attacking problems such as this. Topic number 4, similar figures. What makes figures similar? Figures can be similar if they are the same shape but different sizes. This is not to be confused with the word congruent. We're only looking at for things that are similar. So here's an explanation of what we have here. We have figure A, which is the large square, and we have figure A1, or figure A with a little mark on top, which is the smaller image here. These figures are congruent if they are the exact same shape and size. Figures can be similar if they have the same shape but different sizes. So based on what we see here, we could go ahead and say with confidence that these are similar figures but not congruent. They're similar because they're the same shape, but they're not congruent because they are not the same size. That's it for our chapter review. If you needed to go back and check some other things out, go ahead and do so. Catch you next time.